Moving on towards the first talk of this conference, it will be my honor to introduce Dr. Ali Kashif Bashir, Manchester, Metropolitan University, United Kingdom. He received his PhD in Computer Science and Engineering from Korea University, 83 in QS ranking 2020, South Korea, and MS from Ajo University, South Korea. He is the author of over 150 peer-reviewed articles. He is co-supervising several graduate, MS, and PhD students. His research interests include Internet of Things, wireless networks, distributed systems, network, cybersecurity, cloud network, function virtualization, etc. He is serving as the editor-in-chief of the IEEE Future Directions newsletter. He is the editor of several journals and has served as a guest editor on several special issues in journals of IEEE, Elsevier, and Springer. He has served as chair, program publicity and track chair on several conferences and workshops. He has delivered several invited and keynote talks and reviewed the technology leading articles for journals like IEEE Transactions on Industrial Informatics, the IEEE Communication Magazine, the IEEE Communication Letters, IEEE Internet of Things, and the IEICE journals and conferences such as IEEE Infocom, IEEE ICC, IEEE Globe.com, and the IEEE Cloud of Things. Now, I welcome Dr. Ali Kashif Bashir, Manchester, Metropolitan University, United Kingdom, to share his views on the topic, role of IoT in shaping the future. Please, sir.
Good afternoon, everybody, and thank you very much for giving me this honor to talk to you. It's my honor to be part of this conference as a keynote speaker. I would like to thank all the organizers and congratulate all the organizers. Jan Wyzykowski University, Panipat University, and Panipat Institute of Engineering and Technology, India, and IIS Jaipur. And also, it was a pleasure listening all the guests, all the chief guests, just who were talking before me. And I was just thinking, regardless, it doesn't matter from where we are from UK. We are from India, from where we are all teachers, and we want to deliver the best to our students. So it is my pleasure, it is my honor, and I feel if the only pleasure or honor I feel, that is that I have taught in so many countries across the globe. I have direct students in so many countries, and I have indirect students who I'm supervising all over the globe. So being a teacher, it makes me honored. And thank you again for my friends, Deepak Gupta and Ashish, for giving me this opportunity. I'm going to share my screen. So once you see my screen, just let me know.
Yes, visible.
Wonderful. Just 1 second. Let me just, yeah. Just trying to move this one on the side. Yes, okay. This is the best I can do so far. Yeah. Thank you for the person who introduced me. It was such a long introduction. Thank you very much. My name is Ali Kashif Bashir. You can call me Ali. Today I'm going to talk about the role of Internet of Things in shaping the future. I'm honored to have honorary faculty positions in many countries, in such as in China, in Pakistan, in Canada, and I'm based in UK. In addition to what I mentioned, I have obtained around $3 million US funding, and in my career, about 1.5 million US funding is still under me on different projects. Today, I'm going to talk about the IoT, a bit of the background, and a few of the use cases, and how the IoT is shaping our future. So the one big question we have today is, are we ready for the 5G? We have to ask this thing to ourselves. We have seen 4G, we have seen 5G, we have seen so many applications that are emerging, such as vehicular communication. In vehicular communication, We have now we have semi-automated vehicles on roads. We are moving to fully automated vehicles on road, and then we have the manual vehicles already on road. So after probably 10 years after now, the situation will be completely changed. Most of the vehicles on road probably will be semi-automated or fully automated, where most of the and all of them, they will be having smart technologies, a kind of a smart network within the vehicle that will be communicating with outside the world with through cloud computing, through edge devices, and through so many other things. If I talk about healthcare, in the healthcare, we already having a lot of advancements. We are moving the things that were not possible many years ago. They are possible today, such as one of the project I'm discussing with a few physicians from India and a couple of universities, and that is they have built a device for testing women pregnancy, because in some areas in India, like such as in Himalaya, it is not possible. Those who are women, and I mean, we know that when during a pregnancy, the women has to go to doctor probably every week or every second week for the scanning. But in those areas where the doctor is not available and the transportation is not available, it is a big challenge. So they are building this device where the women can take their scans at home and can send the result to doctor using the Internet of Things, using the internet. So this is one of the example of the e-health. There are so many other advanced examples. There are robots are being deployed. One of the biggest project, or one of the most interesting project that we are discussing here in UK is that virtual clinician. In virtual clinician is that you will be interacting with the system in such a way, with your computer in such a way that that is providing you all the consultancy, a basic consultancy that you require. There will be three ways the system will learn about you. The system will there will be machine learning and deep learning models at the back end, but the system will learn about you from the textual data. The system will ask you a few questions and you will answer them. Your voice data, because you will interact with the system using voice, and your facial expression. The system will read your facial expression. There is no system anywhere in the world that exists who take all these three data parameters into account and then give you consultation. It is a bit ambitious project, but I think this is a time when the science can think of the ambitious projects. The closest model of this we can have is called basically human profiling. The closest model we have to this one is that probably the social networks. For example, Facebook or Instagram, they build our profiles. They know that which object I see for how many seconds. They know which video I see for how many minutes. They know what kind of apps I have installed. They know what kind of other information I'm interested in. So they use that kind of material to build a profile of me at the back end. So based on that profile, they will suggest so many other things, and that is how they will be suggesting a lot of. They are already start suggesting these products for the promotion purpose, and then they will be based on this data, based on this profiling. But in that they only take two kind of data, probably textual data what you post, and the screen time. That is much easier. But once we consider this textual data plus voice data plus facial expressions, this never been done in the world. So this not only help you achieve not only interact with the system, but the system will learn, and then the system will tell you so many other things which the doctor cannot tell. And then we have seen the other advancement of AR and VR technologies. If we talk about the TV technologies, they are also very advanced. Now the TVs are not like the old TVs that we have. Please, sorry for the background noise of my child if you're hearing this one. Also, the artificial intelligence. It is the artificial intelligence that are whatever we have seen so far in 4G or 5G. The biggest change that is going to come into the future is basically because of the artificial intelligence. The artificial intelligence will bring a lot of drastic changes. The way we interact with the technology. Up to previously, it was based on what we think about the technology. In the future, the artificial intelligence will come into play, and then artificial intelligence will tell us that how we can possibly interact with the technology. That is a debatable comment, but that is the way it is. Similarly, there are also all these things, they are coming. There are also the kind of industrial IoT applications. The IoT is being applied in so many other applications where it was not being applied before, such as manufacturing, such as assembly lines, in car manufacturing, in other kind of products like these our shopping malls and so many other kind of applications. So what we need to ask to ourselves is that where we stand here and how we can be part of this one in 6G. Okay, where we are, our universities, our homes, our facilities, are we ready? What kind of change possibly can come that can help us, and that can guide us to improve our life, and what role we can play for that? Yeah, just taking a little bit back. This is for a bit of the background for the students. Yeah, so how does this all happens because of the internet. And when the internet started, it was just started from the US department for just communication, for the communication purpose from one point or one person to the other person. And then we have gone through the different eras, and the last era probably we have seen is still we are going through is a social media, where you interact with the social these platforms, Skype, like Facebook, YouTube, Instagram, and so many others. And then we are already into Internet of Things. Internet of Things is machine to machine, where you just, for any decision to complete any task, the machine will start communicating from one to another. You don't have to to monitor the communication. The communication probably will happen by itself, such as, like, let's say you just order from your mobile phone that I want to have this you want to order something, and the order goes to probably your let's say that it goes to your refrigerator, and the refrigerator does not have, such as, let's say, a milk, and it is not there. Then the order possibly from there, the request or the search request goes to somewhere else, and it keep broadcasting until it find the result and get back to you. So how it happened, why do we call it as an Internet of Things, is because at the moment, the number of devices we are connected on the planet, the devices we are connected to on this planet are 7 to 8 times more than number of people. Okay, if we just think how many devices we are connected to, all of us almost have at least 2 devices, our mobile phones, our laptops, and probably desktops. We also have there are so many other devices, like there are so many sensors, they are deployed there. They have the IP addresses. There are so many cameras, they're there. They have the device, they have the addresses. There are so many laboratories in your university. There are so many computers that are connected to internet 24/7. There are so many data centers, Facebook, Microsoft, Amazon, and so many other data centers. They are 24/7 connected to internet. There are so many other high-end laboratories. They have millions of or thousands to millions of computers, such as NASA or several other laboratories. They are connected to internet 24/7. So if I talk about how much this data is being produced, so this is just a basic table. It gives you all these dynamics of 60 seconds. For example, in one minute, the emails that are being sent are 200 million emails across the globe. 4.2 million Google searches, 480,000 tweets, 60,000 Instagram uploaded, and 4.7 million YouTube videos are viewed. So this is a huge volume of data, and their data is just being produced. So what we are today, all the technology we have today, is a result of all this data. Okay, the data have shaped all the data plus the it is hard to say whether the data drive the internet speed or internet speed drive the data. Both are very closely interlinked with each other, but together we have gone through with the several stages. For example, the things start happening from when we had some applications for the bus traffic, such as the bus traffic example could be in 2012, I was working with one research center in Korea. That is, we were that project I was working on is still one of the world biggest project. They plan to produce a fusion energy by 2050. I mean, the project will go on up until 2050. So they plan to produce fusion energy just the way it is happening in the sun on this planet. So for that, they're bombarding so many kind of atoms on nuclear material, and from there so many kind of rays are being generated, so much data. For example, at that time, now I don't know, I mean, I'm talking about 2012. At that time, from one experiment, probably I think 1 to 5 terabytes data is being produced in few seconds, and the data is need to be stored in the data centers. And then we have the collaborators were 7-8 countries: USA, UK, Japan, Italy, France, and China. So several researchers, and the centers were only in 2 countries, in Korea and in France. These are these atomic reactors. So the atomic reactor was only 2 countries. So what they do is, like, so we have to share those data with all the experts. Okay, so we need those channels that can propagate this heavy data from one point to another point, because the next experiment is due probably in an hour or in 2 hours, and next experiment is going to be happen on the outcome of the previous experiment. What parameters were set there, what need to be changed in the parameter to get more accurate result or better result. So this require elasticity in the solution. For example, all the data centers we have, we require more data centers. We need more elastic solutions that can cater this kind of bus traffic. And from there, okay, then there was another era we moved to, which is resource integration. I'm talking about elasticity of the resources from where we can store the data, such as data centers. From there, we move to resource integration. Okay, the resource integration is that there were on internet previously. If we talk about the internet was only probably one public company that is providing internet to everybody. But now we have so many other kind of stakeholders. They are taking a lot of share. They are having a chunk of something. They are taking resources from one places. They are itself a resource provider, or maybe they are taking resources from several other providers and serve us as a resource provider, such as, I mean, eBay. eBay does not have its own data center or own warehouse. Okay, so the eBay takes services from one place to another place and offer us in such a way that we don't feel any difference when we are interacting with eBay or Amazon. So these kind of service providers, when they come, so the resource start integrating into, so we felt the need that we have to virtualize for 2 reasons. The data centers, we have to virtualize our resources for 2 reasons. One is for security, and the other is for the dedicated services and dedicated virtualized services to each provider. And from there, once we have the dedicated services, that led to the open source software as open source, because if I have a dedicated network, I can change the networking the way I want. Probably my needs change over the time, and then from there, for that we have the STM technology. So that's what we have gone through. And if we talk about the IoT framework, I just want to give example to this, because sometimes the students, they don't really understand what the IoT is, because we talk too much. But some of them, they think the IoT is probably only taking a data. That is also taking a data and storing it cloud. That is also part of IoT. But I just want to give an overview of a big picture of the IoT. For example, here you think about, these are the edge technologies. These are the different applications we have, such as there is a ship in the sea. That ship is containing a lot of items, and those items were, let's say, before IoT, they were containing, they were attached. Probably there was some RFID tags were attached, because and those RFID tags are being read by the reader, because it is very difficult to manually monitor everything on a ship, because ship is going to stop at several ports. He's going to load off something and load on something. So if there is a reader, but the reader it is a edge technology. It was a standalone technology. It was not communicating with anything else. So and similarly, your traffic or any other thing, if the traffic was probably there, but if it is not connected to let's say the outer application through the internet, then all we can do is only we can just optimize the traffic, but we cannot, such as I want to go to from India, I want to go USA, and I want to receive a package, and I have a stopover, let's say at Singapore. I want to receive a package there, and the package is coming from somewhere like Thailand, and it is in another flight or in a ship. If all these technologies, they are not connected with each other, okay, then I cannot plan my tour. I need to have an idea when the package is going to reach there at the Singapore airport. So either I do it manually, or it is that I could do it totally automatically. So the point here is that I have divided this IoT framework in few steps. What we need to do here is that any device or any technology or any edge technology that want to participate in IoT, we need to allow the objects in the technology to participate. Such as here, in the example I gave, objects in a ship in a sea, they are already they have infrastructure, for example tags and readers who can read it, so they are already prepared. If they are prepared, what next we do, we need a middleware architecture to share data between different kind of applications. And if the architectures are there, then we need some kind of communication protocol. What kind of protocols, what kind of packets we are going to use to traverse data from one application to the other application. And once the application are traversing data from one point to another point, then we need a decision making. It could be you are making a request from your mobile phone, and the decision is being happened. You see that decision is happening and come to your mobile phone, but actually the decision is not happening at your device. For example, think about your Facebook data. Do you think that is stored on your device? No, it is not stored on your device. Think about your Google query. It is coming from your device. No, it is not. So the decision is coming from somewhere else. We are just so that data, all these data, all the inputs are coming and being stored at the data centers. If it is going to being stored at the data centers, we have to provide a logical or a seamless connectivity to every device or every application to that data, regardless where the application resides. The application could be from in India, in UK, or in England, but we are going to have a seamless access to all these resources, and it is going to be provided to us from the cloud. That is how we call it as a cloud. Is a somebody else computer. It is a computer, but to us it is we don't know where it is, so we call it a cloud. It is coming to us somewhere, very near to us. That is what we are giving the concept of. But so actually it is stored somewhere else. Smart city is the biggest example of like IoT and cyber physical system. These terms can be used interchangeably. Smart cities are a best example of cyber physical systems or IoT technologies. There could be a lot of things like there could be intelligent sensors deployed on the road. There could be a lot of e-health care provider hospitals. There could be other smart agriculture or smart transportation. All of these, when we talk about so the smart cities is a perfect example of these cyber physical systems. So the goal of this one is that to providing safety, security, financial, and environmental benefits to everybody. Next, I want to talk about a few of my ongoing projects. The one project we are applying VNF, virtual network functions, in several application areas. We think the VNF is a solution for reprogrammability. Reprogrammability is one constraint we have in many devices, such as think about a router. What the VNF does is that it decouples, I'm not going in depth of this one, it decouples software from hardware. The best example easy example I can give is think about a router. What is a router to you? When you think of a router, a device comes in your mind that has a routing functionality. So it is what it is. It is a device. It is a software attached to a hardware. Actually, the device is having a capability to perform the software function. But if the software is taken away from the hardware and offered to all the devices that has the capability to perform that one, so it means that we have decoupled that one. And for example, if my mobile phone has a capability to run that software, then my mobile phone can be a router for my home network. My laptop can be a router from my home network. So this is a basic example I can give you for the so once that software is decoupled with from the hardware, it can be offered anywhere in the virtual environment. One example is that think about a robot chef. The robot chef you buy, let's say you're coming to UK and you buy a robot chef here, and robot chef is like prepared to, let's say, is trained to prepare breakfast, English breakfast. But you take it to India and then you put him in the Indian kitchen, and then there he see like belna kind of thing, and then he sees like flour and other kind of items which he's probably he's not supposed to understand. So what he does, he take a picture. I'm talking about a perfect ubiquitous environment. He take a picture of those items and he put it on the internet, and then based on those pictures, the image processing started coming into play. And image processing now these days is very accurate. So on the base of the results come as, like, let's say he received 5-10 results. Like the first result is that, oh, you can make a paratha out of this one. With the result came with a probability of, like, let's say the 99% is it is paratha. Okay, so he just clicked that one, and in the milliseconds a new software is being downloaded on his hardware, and he can perform. Similarly, these cameras deployed on the roads, or these sensors deployed on the roads, they are programmed for a certain task. But if something happens, like let's say a terrorist activity happened in the city, then for these technologies, sensor and cameras, that terrorist vehicle is one of the 100 vehicles. These sensors are not that intelligent that until you apply a filter something somewhere, but they are going to read that one with the same probability as the other vehicle. But if you change the probability of or programming of those sensors and tell them that your first priority is just to monitor that vehicle, so the result and the accuracy, latency will be totally different. There are a few other areas where we can possibly apply VNF, but I'm not going in detail. Second project we are working on is we have 26 organizations from 6 countries like UK, Portugal, Spain, Turkey, Czech Republic, Canada, and South Korea. We are proposing smart homes for old age and sick people. Here we are deploying pressure sensors in the floor. We already have smart homes solutions, but they use either they use either those wearable devices. The wearable devices has some limitations, such as these old and sick people. They are already old and sick. They are not technology savages. They are not technology friendly. They don't want to wear anything, so they are uncomfortable, or maybe physically they are not capable to wear anything. Or probably the other solutions we have are the cameras. The cameras have other limitations, is the privacy. Are you going to watch somebody when they're in bed? Are you going to watch them when they're taking a shower? That is another challenges. But if there are pressure sensors, the pressure sensors, they monitor the movement, and then On the basis of the movement, they build the models, and if they see anything and any drastic changing in the movement, the way the person moves, they can inform the technology providers. And then using NFV, then we propose one fog layer, one cloud layer. I'm not going in detail of these technologies because of the shortage of the time. So here, this is we have 500,000 pound for the UK partner for this project. The third problem, actually not the project we're trying to convert into. We propose a phase of this project in China from one university with a couple of my students. All of us, all around the world, we have this challenge of the weather, extreme conditions. We have some disastrous conditions when we are limited to drive, such as it could be smog or fog in some areas on the planet, or in some countries where for certain hours, such as from late evening to until 10 a.m. or in the morning 10 a.m. 11 a.m. you cannot drive because there is a heavy fog or smoke on the roads, and in some areas the clouds are so low, and if there is nothing, then still you have a problem of driving at high speed on night on a rainy day. You cannot see, and these things likely, if you have these smog or fog issues, if you does not drive, that is a huge burden on the economy, because the economy, the road is a backbone of the economy. Similarly, it could be dangerous for the livestock on the roads, or even human lives. So what we are proposing is that we have the GPS system, but we are proposing ideally, this is last phase, not the first phase we are working on, that we have a live assistance on parallel to us. We have a human eye probably in these situations are in some conditions. When I was in Denmark, I was on a planet. I was on island, and sometimes the clouds come so low that you cannot see probably after 30 meter or 40 meter. And when you're driving, on one side you have a mountain, on the other side you have a sea. So you don't even know whether after 30 meter or 40 meter either you're going into the sea or you're going still on the road. So if you have an assistance there, then that is telling you that you are on the road. The road looks like, because with a naked eye you cannot see. Plus, you can apply these kind of these high-end devices, high-end vehicles. They have already started using these sensors like LiDAR sensor, but they have their limitation. We are using triangulation. We are using several kind of data. We are using the device data. We are using the vehicle data. We are using the GPS and satellite data, and we are using the data of previous vehicles in the roadside beacons. So all of them there we are using. Still, it is a quite challenging project, but we are working on this one. So what we are currently trying to do in the first phase, we are trying to do the road profiling. Another project we are working on is like for $220,000 project. We have here a Packaging Automation Limited, which is one of the big companies in UK, who provide these packaging to all over, so many supermarkets here in UK and in Europe. We are, they have their assembly lines. We are taking the data from the packaging data from the assembly lines, and we are storing them in cloud and applying machine learning algorithms and providing different kind of visualization and searches to all different kind of customers. For example, maybe one brand in one chain of superstores, they want a different kind of view in UK, but the people in Europe, they want a different kind of view. So we are working on this one. Another project my PhD student is working on, we recently submitted it to the IEEE Transactional Industrial Informatics, and here we are trying to solve, using VNF, we are trying to solve the problem of spectrum allocation in the cognitive radio networks. We have a big problem of spectrum wastage, so we are trying to solve that one. And the other project which is very close to my heart, that is I mentioned on the first slide, that universal Clinician, where we are using several kind of data inputs to provide. We don't know how much successful we will be. This is a very long project, very big project, but here we have NHS, National Health Service UK, on board with us. So yeah, this is a end of my talk that I want to share with you. It's my pleasure again to speak to all of you, and you're welcome, all the students, all the collaborators who want to work with me, or you who want to, or I possibly can learn something from you. You're welcome to connecting with me on LinkedIn or on Facebook. You can search me with my name. And I'm also being an editor-in-chief of this newsletter, IEEE Ethics and Policy and Future Direction newsletter, which is also called IEEE Future Directions. We usually publish short articles, 800 to 1200 word articles, providing the conceptual, not the technical details, but the policy aspects, the technology being applied in the society aspect, or the ethical aspect of the technology. You are welcome to submit to the managing leader, which is FD Policy Ethics at IEEE. You can also Google this one and you will get to know. Yeah, thank you for listening.